Now let's talk about geospatial indexes that consider the curvature of the Earth. So a spherical model of the Earth, which is the Earth we really live in. Now, in a spherical model of the Earth, the locations on the Earth are usually specified by longitude and latitude. And the lines of longitude go from one pole to the other, and the lines of latitude come around the Earth like that. And I'll just draw in the equator in red. This is my equator in red. Now, if we're closer to the equator, then the lines of longitude are further apart, and as we get to the poles, the lines of longitude are closer together. Now, if you have a person standing anywhere on the Earth, you have a person standing right here, you might want to figure out, well, what are the different locations, the different stores that are near him? You can do that using the spherical model by specifying a max distance that will accept documents that satisfy that max distance criteria, and then we want the database to return the documents in order of increasing distance. That's all good. Now this max distance is going to be specified in radians. Let's have a little math review here. So if you have a circle, and if you have a distance, let's say that's specified in meters, this distance d that I'm showing in red, then the distance d swept by the arc theta is equal to pi r, where r is the radius of the Earth in meters. So if you know the distance, you say, oh, I want it to be, I want to find every document within 100 meters of this location, then the arc in radians is the distance you're looking for, let's say 100 meters divided by the radius of the Earth in meters. And then you'll get to the angle theta. And that's the way you're going to need to specify any max distances in this model. Now, the spherical model was introduced after the 2D model in MongoDB, and so it uses some of the same facilities, even though it is a spherical model. In particular, when you put an index on the location inside the document, you're still going to say that it's of type 2D, even though, I consider this to be more of a 3D model. I guess it's only looking at the surface of the Earth, so you might call it a spherical model, but you still call it a 2D index. And the difference is that when you query it, you're going to query it in a different way. Now let's look at how we're going to query it. Now I've got the same collection here I had before, my stores collection, and I'll just remind you what's in that. I've got 3 documents in there, and they've got locations listed as arrays. Now, before, I told you they were XY coordinates and that it could even be YX, and it wouldn't matter because in Cartesian geometry, it wouldn't matter which it was. But in this spherical model, it very much does matter, and these have to be considered to be longitudes and latitudes. So remember, it's longitude comma latitude, not latitude comma longitude. And so we're going to consider these to be longitude comma latitudes in all these documents. Now there is a 2D index already in here. If you remember, if you do a get index, you can see it. I'll do it again, just so that this lesson can stand alone. You can see that there's something on location right here, and it's marked 2D, although we're going to use it in a way that gives us a 3D distance from a particular location. The syntax looks like this. It uses the geonear command, and rather than being used with the find, you use run command, which lets you run a whole host of commands to the database. In this case, we're going to specify that geonear is the one we're looking for, and that we want it to look in the stores collection. Now, stores has to be specified explicitly because it doesn't say db.stores here, it says db.run command, so that the database would have no way of knowing that you want to look in the stores collection unless you specified it here. And then it's near this location. Again, it's longitude comma latitude. I specify spherical is true, which tells the system, the database, that I'm looking for the spherical model. And then I specify a max distance of 1 radian. 1 radian is, there's 2 pi radians, about 6 radians all the way around the Earth. So it's like, 1/6 of the way around the Earth. And if I do that, is what I get. I get this rather convoluted return document. And if you look here in results, that's where the action is. That's where over here, this object, that's the actual document from the collection that satisfies the criteria. And if I gave a larger max distance of, let's say, 3 radians, which is like half the way around the Earth, at that point all the documents are going to satisfy that, and they're going to be returned in order of increasing distance. So the same one is returned first, which is the Ruby's Barber 4074 Let's see, make sure that's true. Yep, that's true, that's good. So this is still the closest one. But now that we've opened up the max distance, we're also getting the Ace Hardware store and the Tickle Candy store as well. And that's how you use the spherical model. So just to review, you store the locations much as you did before in a key of your own choosing with an array with 2 values, and it has to be longitude, comma, latitude. You ensure an index on the collection of type 2D, although we're going to use a spherical model to query it, and then we use this run command, geonear, with a bunch of parameters that will let you look up any of these documents to find out which documents are closest to a particular location, and specifying a max distance if you want. Now, there are other options to these, and there are other details and limits and conditions and other things that I haven't completely gone through in this lesson. So you'll have to look up in the documentation if you want to learn more about these geospatial indexes. But it's really convenient if you want to do location lookups inside MongoDB.